Still looking at trig equations, but a very specific type of an equation. And we're going to look at a couple of different ways we can approach to solve this. So it's one that's in this form. Some constant times sine x plus some constant times cos x equals a constant. And that constant number is not 0. Because if it was 0, we could move the cos x to the other side and create a tan x by division. But if it's a different constant, we can't. So the first idea is to use the t results. And what we end up doing is we turn a trig equation into a quadratic equation. So here's an example. 3 cos theta plus 4 sine theta equals 2. So I'm going to say, okay, well, let t equal tan theta on 2. And my new equation becomes 3 outside of 1 minus t squared on 1 plus t squared, plus 4 lots of 2t on 1 plus t squared is equal to 2. But notice this. Remember, we're looking for solutions between 0 and 360. But I've now changed the angle to theta on 2. So now I'm only looking for solutions in the first or second quadrant. So between 0 and 180. All right, let's multiply everything by 1 plus t squared. Move everything to one side. There's my quadratic equation to solve. So t equals negative b plus or minus square root of b squared minus 4ac all over 2a. 8 plus or minus root 84 on 10. Root 84, well, 4 definitely goes into that, doesn't it? So I now have two possibilities. Either tan theta on 2 is 4 minus the square root of 21 on 5, or it's 4 plus the square root of 21 on 5. Well, let's look at the 4 minus the square root of 21 on 5. Which quadrants am I in? 2 and 4, why? What's your logic? Right, half right. Which quadrants are we in? Just 2. Remember what I said? We're now just looking for solutions in the first 2 quadrants. So we're only looking for one answer here, in quadrant 2. Because, yeah, sure enough, that would be a negative number. So the equivalent acute one, 4 minus root 21 is a negative number. So if I swap it round, I'll get the positive number. Mind you, with your calculators, all that will happen, if you go 4 minus root 21 on 5, it'll give you the negative acute anyway. So you'll get the acute, 6 degrees 39. We're talking about in the second quadrant. So second quadrant would be 173.21. That's theta on 2. So now we double it, and we get our answer, 346 degrees 42. That's one answer. Okay, 4 plus root 21 on 5. Which quadrants are we in? Yes, it's just the first quadrant, not the first and the third. So first quadrant. So it is in fact the acute angle we're looking for, which is 59 degrees 47. So theta on 2 is 59 degrees 47. Double it, we get 119.33. So there's our 2 solutions. However, the thing about the t results is it will never find the solution of 180 degrees. Why? Right, because we're doing tan theta on 2 and tan 90 is undefined. So therefore we never get the possibility theta is 180. So we just need to physically test to see if it is a solution. So 180 degrees, if I sub that in, cos of 180 is negative 1. Sine of 180 is 0. No, it's not going to work, is it? Okay, so we only have 2 answers. Okay. And that's the way a lot of people feel comfortable doing it. And it works, and that's fine. There's this other way of doing it called the auxiliary angle method. This method has advantages in other areas that we end up looking at. So it's still a good method to know, even if you do prefer the t results way of doing it. And the reality is, they might ask you to do it a specific way. So you've got to know both ways. What we do is we get those 2 functions and turn it into a single function. I'm going to turn it into a sine function. So same question. I've got something times cos, something times sine, and it's equal to 2. But I want that something times cos plus something times sine to be a single sine function. Well, we know sine cos, cos sine, is a sine function. And that's what we're going to do. We're going to turn it into that. And here's how we do it. Right. So there's our equation. 3 cos theta plus 4 sine theta is equal to 2. I know I sort of want it in this sort of feel. Sine alpha cos theta plus cos alpha sine theta. I've got the cos thetas, I've got the sine thetas. Obviously it's got something to do with these numbers 3 and 4. Now, sine alpha can't equal 3 because sine goes in between minus 1 and 1. And cos alpha can't equal 4 for the same reason. However, I can use those numbers. If I draw up a triangle, and okay, sine alpha can't equal 3, but the opposite side can. So, because it's sine, I'll put 3 on the opposite side, because sine is opposite over hypotenuse. And then cosine is 4. Well, again, cosine can't equal 4, but the adjacent side can. And so I'll make the adjacent side 4. Bit of Pythagoras, and I can work out the hypotenuse. Now, I rewrite it. Now, I don't normally put this step in, but this is just to show you where it all comes from. Because if what I do is now divide everything by 5 and multiply by 5, I'm okay. Because, yeah, sine alpha can't equal 3, but it can equal 3/5. Cos alpha can't equal 4, but it can equal 4/5. I can't just change the question, because I've divided by 5, I've got to multiply by 5. So I've got 5 times my sine cos cos sine. I say, I don't normally write that line in. I normally just go straight there and say, I know I've got 5 times, I'm turning into a sine function, and in my one, it would be alpha plus theta equals 2. That's my new equation. Question is, what's alpha? But I've got a triangle over there that will let me find alpha. So the hypotenuse will always turn out to be the coefficient of my new trig function. Okay? We use one number to be the adjacent, one number to be the opposite, and then that'll create a hypotenuse, which will become the coefficient of my new trig function that I'm working on. And then I can divide by 5, and I've got a very simple little equation to solve. The sine of something is 2/5. To work out the alpha, I can go back over to my triangle. Tan alpha is 3/4. So alpha is roughly 36 degrees 52. Back to here. Sine is positive, so I'm in quadrant 1 or quadrant 2. So the acute angle, which I can't call alpha this time because I've used alpha for something else, so I've just called it beta. The acute angle is 23:35. So alpha, 36 degrees 52, plus theta is either 23:35 or 156.25. Well, subtract 36 from both sides and we get the same answers almost. There's the 119.33 that we got before, but I've got this other answer, minus 13.17. And that's because I've taken away that 36. I've ended up in the negatives. Well, that's not the answer I'm looking for, because we want to go between 0 and 360. So all I do is add 360 to that negative one, and we get the same answers we got before. So 119 degrees 33, 346, 43. Where does this have its advantages, this idea of turning the two trig functions into one? Later on, when we start graphing some of these more complicated trig functions, rather than trying to graph, imagine instead of 2 that was y equals. Instead of trying to draw y equals 3 cos theta plus 4 sine theta, it's a heck of a lot easier to try and draw y equals 5 sine of something. It's just one single sine curve. Bit of a shift happening, but we can do it. So that's one of the huge advantages that it does have. Hey, I chose sine. I could have easily done cosine. Let's do the same problem again. There is 3 cos theta plus 4 sine theta equals 2. This time I'm going to turn it into a cosine function. So the pattern would be cos sine sine. Exactly the same idea. There's my triangle, but this time cos alpha is representing 3. So I'll place 3 on the adjacent side. 4 is representing the sine alpha. So I'll put 4 on the opposite side. Amazingly, the hypotenuse is still 5. So my new function, again, probably wouldn't write that line in. I'd go straight to, okay, I've turned it into a cosine function. It's 5. Be careful though, because remember, if it's not the sine, it's not the sine. So it's theta minus alpha or alpha minus theta. It really doesn't matter which way you write that, because remember, cosine is an even function. So I tend to put the theta first. I just find that a bit easier. So cos is 2/5. The alpha will change though, because now the opposite and the adjacent have swapped round for this problem. So alpha in this one's 53 degrees 8. Cosine's positive, so I'm in the first quadrant or the fourth quadrant. The acute angle then in this one is 66 degrees 25. So theta minus alpha, 53 degrees 8, is equal to 66 degrees 25 or 293.35. Let's add 53.8 onto both of those, and there's our two answers, the same again. So unless they actually ask you, you could choose. Do I want to turn it into a sine function? Do I want to turn it into a cosine function? It's up to you. Sometimes they'll actually say, turn this into a sine function or things like that. So here's one from an HSC. Typical sort of question where they haven't actually worried about the equation. They've simply just said, look, go and express this as a single trig function. So it's the same idea. We're just looking at this and turning it into our sine function. So I'd go, oh, well, okay, root 3 sine 3t minus cos 3t. I'm turning it into a sine function. So it would go sine, cos, sine. So in this case, it would be sine 3t cos alpha. So the root 3 is associated with the cos. That'll be the adjacent side. And sine alpha, well, we don't normally write the 1 down, but 1 would be on the other side. So let's put those in. Hypotenuse turns out to be 2. So I know that's 2 sine 3t minus alpha. So I'm saying I don't normally put that middle line in. I just go straight to hypotenuse. I've turned it into a sine function. It's 3t minus alpha. I now just have to work out what alpha is. It turns out to be the exact value on this one. So it's 30 degrees. So that would be 2 sine 3t minus 30. Changed. Let's try another one. This one came from the 2003 paper. This time they wanted us to turn Sine X minus Cos X into a cosine function. Okay? So same idea. Well, if it's a cosine function, I would have gone cos, sine, sine. Oh, damn, it's sine minus cos. I'd rather have cos minus sine. Well, that's not a big deal. I can factorise out a -1, and then I've got cos minus sine inside. Now, cos, so 1 is on both. So the sine's 1 and the cos is 1. Hypotenuse is root 2, so I've got minus root 2 cos of x minus alpha. Just need to work out alpha. Again, one of our exact values, 45 degrees. So I get minus root 2 the cos of x minus 45. So that's the basic idea behind what we call the auxiliary angle method. So 2e, it's got a mixture. Sometimes they'll ask you to do the t result. Sometimes they'll ask you to do the auxiliary. If they don't, you might even like to have a go at both until you're comfortable with both and go, oh, actually I prefer this way or I prefer this way. Because as I say, if they don't actually ask you, then you can do it whichever way you like. It's whichever way you prefer. But you do need to know both ways of doing it.